Did you know there is a bottle of oil sitting in the pharmacy aisle of your grocery store right now? Not the auto parts store, the pharmacy aisle, that powered the rotary engines of Allied combat aircraft in World War I, that the entire German war machine scrambled desperately to replicate and never could, and that has a documented, peer-reviewed property that almost no modern mechanic will ever bring up in conversation with you. It costs $3. It's been sitting on that shelf your entire life. And what it actually does, and why the auto industry stopped talking about it, is one of the most interesting pieces of chemistry you'll hear about this year. By the end of it, you'll probably be saying, "Wow, Sydney, I had no clue about this." Stick around, because I am going to show you exactly what this oil is, why WWY pilots owed their lives to it, what it does to rubber engine seals that petroleum oil cannot, where it genuinely helps a leaking engine today, and where it will not, because this channel gives you the full picture, not a sales pitch. But first, think about what you know about World War I aircraft. The Sopwith Camel, the Fokker triplane, Manfred von Richthofen, the Red Baron, dying in the cockpit of his. These planes were powered by rotary engines, an early design where the entire engine block spun around a fixed crankshaft, propeller bolted directly to it, engine and propeller turning together as one spinning unit. Excellent power-to-weight ratio, outstanding cooling, mechanically elegant, and they had one extremely specific requirement that shaped the outcome of the air war in a way nobody ever talks about. They needed castor oil. Only castor oil. And nothing else worked. Here is why, and this is where the chemistry starts. Rotary engines ran on a total loss lubrication system. Oil was continuously fed into the spinning engine and ejected from the cylinders in a fine mist with the exhaust. It did not recirculate. It burned. It sprayed continuously out of the engine into the open cockpit onto the pilot. An 80 horsepower Lerone rotary engine lost 6 quarts of castor oil every single hour of flight. The oil and fuel mixed inside the crankcase under extreme heat and pressure. Any lubricant that would ignite on contact with fuel would destroy the engine and the man flying it. Petroleum-based mineral oil ignites on contact with fuel. Castor oil does not. It is a triglyceride, a plant-based fat, and it remains chemically separate from petroleum fuel even under the extreme heat and centrifugal force of a spinning rotary engine. It could not ignite with the fuel because it could not combine with it. The Allies understood this and built their entire rotary engine strategy around it. Germany understood it too. As the war wore on and Allied naval blockades cut Germany's access to castor oil imports, German engineers tried petroleum-based substitutes. Those engines ran hotter, failed faster, and had significantly shorter service lives. Castor oil, or the lack of it, was a direct documented factor in the degraded reliability of German rotary-engined aircraft in the war's final years. Now here is the part of this story that nobody mentions in the history books, and I want you to know it because it is genuinely remarkable. The pilots flying those castor oil lubricated engines were being continuously misted with it from the exhaust. Castor oil, as you may know, is also a powerful laxative. The combination of castor oil inhalation, altitude, and combat stress meant that every pilot flying a rotary-engined aircraft was managing a very specific and very uncomfortable physiological problem for the duration of every mission. The solution the Royal Flying Corps landed on was to issue every pilot a flask of blackberry brandy to counteract the laxative effects in flight. America's top ace of the war, Captain Eddie Rickenbacker, was so badly affected that he was famous around his aerodrome for running around the corners of buildings after landing to vomit from the combined effects of air sickness and castor oil exposure. He eventually got control of it and went on to become the highest scoring American ace of the war. And the silk scarf, the iconic image of the WWI aviator, was not a fashion statement. It was a tool. The white color was deliberate. Pilots wiped castor oil off their goggles mid-flight with their scarves, and they needed the scarf to be white so they could see which portion was already oil-soaked and which was still clean. That is why the scarf was white. That is why it was silk. Fully documented. The chemistry that those pilots endured, the kind that won air battles and lost them, that made and broke engines, costs $3 at your pharmacy. And here is what it specifically does that matters to your engine today. Parker Hannifin, the company that literally wrote the O-ring handbook, the definitive engineering reference for seal and gasket compatibility used by mechanical engineers worldwide, specifically lists castor oil as safe for natural rubber seals. Not cautiously compatible. Safe. Petroleum oil attacks natural rubber, swelling and degrading it. Castor oil does not degrade natural rubber seals. This is not a claim. It is documented in engineering reference material that has been used in manufacturing for decades. One British manufacturer of small sleeve valve engines documented something further. that castor oil used in small percentages in their engines produces a fine varnish layer on valve surfaces that actually improves the pneumatic seal over time. The varnish fills microscopic surface irregularities in the metal and rubber contact surfaces, reducing the gap through which oil can escape. This is a documented, observed, real effect. The same gum-forming tendency that made castor oil unsuitable for modern recirculating oil systems, where that varnish would clog passages, but which in specific applications creates a better seal with use rather than a worse one. That is the honest kernel of truth behind the claim that castor oil can help a leaking engine. It is real, it has a mechanism, but that mechanism has specific conditions, and knowing those conditions is the entire difference between this being useful and being a $3 mistake. Modern engine seals, the valve cover gasket, oil pan gasket, crankshaft, and camshaft seals are almost universally made from nitrile rubber. Nitrile was developed specifically in the decades after World War I, in direct response to the failure of natural rubber to withstand petroleum-based oils. It is engineered to resist oil absorption. That is its primary design purpose. The seal softening mechanism that works effectively on natural rubber, oil penetrating the rubber, softening it, allowing it to swell back toward its original dimensions, does not work the same way on nitrile. You cannot soften. A material engineered specifically not to absorb what you are putting in it. What castor oil does offer any engine is this. It has a significantly higher viscosity index than most petroleum base oils, meaning it thickens less at high operating temperatures and maintains its film thickness better under load. In an older, high-mileage engine with worn bearing surfaces and minor clearance gaps producing lower than ideal oil pressure, a small quantity of a high viscosity index oil can increase the film thickness at those surfaces. More film coverage means less oil escaping through the gap. This is not seal conditioning, it is viscosity management. It is real, it is measurable, and it is why some older high-mileage engines respond visibly and quickly when you add something with higher viscosity stability to the oil. Here is exactly where it can genuinely help and how to use it. If you have an older vehicle, older meaning pre-1990, an era when natural rubber seal compounds were significantly more common in engine construction, with a slow seep from a valve cover, timing cover, or oil pan gasket that has dried out and shrunk with age and heat cycling, adding a small amount of castor oil to your existing engine oil is worth trying before spending anything on a repair. The mechanism is real for those seal materials. The oil will not harm your engine. It will not separate from or react with the petroleum-based oil already in the system. It circulates to every seal surface in the engine, and the softening effect, where it occurs, develops over days and weeks rather than hours. The amount, 1 cup, 8 fluid ounces, added directly through the oil filler cap with the engine at normal operating temperature. Drive normally for a week, and then check your parking spot. If the seep is reduced meaningfully, you have your answer. If there has been no change after 2 to 3 weeks, the seal has either failed beyond the point where oil chemistry can address it, or it is a modern nitrile seal that will not respond to this approach. At that point, a mechanical repair is the correct next step, and this was always the honest next option. For any vehicle, regardless of age, if you are losing more than a quart of oil every 1,000 miles, or if what you have is an active drip rather than a slow seep, do not add anything to the oil and drive away. That is a mechanical failure requiring a mechanical repair. Adding any additive to a significant active leak buys no time and wastes the little you have before running low causes engine damage. 2 practical points before you go. Pure castor oil only. The bottle should say 100% pure castor oil with no additives. The cold-pressed pharmacy aisle bottle, the same one sold as a laxative and used as a hair treatment, is the correct product. Cold-pressed, not hexane-extracted industrial grade. And do not exceed 1 cup per oil fill. More does not perform better. Castor oil does not fully integrate with petroleum motor oil the way engineered additives do, and exceeding the ratio can create inconsistencies in the oil system. The pilots of the Royal Flying Corps carried blackberry brandy and white silk scarves and trusted this oil to keep their engines running at altitude over the most dangerous skies in history. The chemistry that made it irreplaceable in 1917 is documented in engineering manuals, military records, and aviation history. Whether it will help your specific engine depends on what your seals are made of and how far the leak has progressed. But for $3 on a pharmacy shelf, it is worth understanding. And now you do. Now you know. And you won't forget it. Thanks for watching, and I'll see you in the next one.